to you about the solid liquid extraction. Filtration is the removal of solid particle from a fluid by placing the fluid through a filtering medium on which the solid are deposited. The fluid may be liquid or gas. The vapour stream from the filter may be the fluid, solid or both. There are many industrial filters such as pressure filter, vacuum filter or centrifugal filter and separator. Filters are divided into three types, which are cake filter, clarifying filter and cross-flow filter. Cake filter spray relatively large amount of solid as cake of crystal or sludge.
So now, I am going to summarize the 4 factors that influencing the solid liquid extractions. There are 4 factors which are particle size, solvent, temperature, and agitation of the solvent. Okay, particle size. When the particle size is smaller, the greater the interfacial area between the solid and the liquid. Besides that, when the rate of transfer of material increase, the smaller the distance of the solute must diffuse winding the solid. Okay, next is solvent. Okay, when the solvent has a low viscosity, therefore it is easy for it to circulate freely. Besides that, it is easy to remove from product liquor by a flash vaporization too. So move on to the next factors, which is temperature. So increase the temperature will increase the solubility of the material which is being extracted to give a higher rate of extraction. Furthermore, the diffusion coefficient will increase with the rise of the temperature, and therefore it will improve the rate of the extraction. So the last factor is the agitation of the solvent. When the eddy diffusion is increased, it will increase the solid liquid mass transfer coefficient of material from the surface of the particles to the bulk of the solution.
For startup procedure, materials needed in this experiment are calcium carbonate and water in the tank of 200 liters for making carbonate slurry. First, dissolve 3 kg of calcium carbonate into the 5 liters of liquor and transfer it into the slurry tank. To get the required slurry concentration, different rate of concentration of calcium carbonate will added with water. So, in 100 liters of water, 3% weight is calcium carbonate slurry. Then, switch on the main power supply. Next, check all the pump, filter, plates and valve, and the experiment is ready to be run. For the experimental procedure, there are few steps need to be followed. Firstly, the air regulator outlet valve must be opened and pressure gauge setting also need to be checked. Release the hydraulic pump air valve and the knob of operation valve with anti-clockwise direction to release the hydraulic pressure. Pack the filter press by packing it towards the stationary pattern and dress up the filter closed with braces. Move the pattern towards the filter plate pack, lower down the truss bar and align it with the hydraulic piston. Make sure no crease is formed. Put the PVC jig tray towards the stationary pattern at the bottom of the filter pack.
Okay, now I will explain to you the calculation for solid liquid extraction. Okay, now I will explain how to construct right angle triangular diagram. First, we need to plot line for all underflow. So the graph is XS versus XA. XS stand for solvent and XA stand for solute. And after that, we plot the value of Y1 and X0. We will get the value from the material balance of ongoing overflow. So after that, when we get the value, we drag from Y1 straight to X0 and straight to the bottom here. After that, plot the value of xn. The value of xn is always on the underflow line. So from here, drag across the value of xn here and straight to the bottom here. So the intersection here is the value of f prime. Okay, next, find the value of x1 by drawing the line from origo to y1. So from here straight to the y1, and we get the intersection with line between this line and the underflow line. So this intersection is the value of x1. Okay, after that, find the value of y2 by connecting f prime, x1 and overflow line. From here straight to the x1 and straight to the overflow line. So the intersection here is the value of y2. And then find the value of y2 here and x3. So from here, x2, I'm sorry, x2. So from the origin here straight to the y2, and the intersection here is the value of x2. So again, from the f prime straight to the x2 and straight to the overflow line, and we will get here the value of y3. And same as before, from the origo straight to the y3, and the intersection is here is the value of x3. Okay, that's all. Thank you.
So hi everyone, I'm Saida Hazira. I will continue with the discussion of the solid-liquid extraction. So generally, a total solid-liquid extraction process includes the preparation of the extraction material, separation and recovery of the solvent from extract, separation and recovery of solvent from the extraction residual. This is the extraction system. So the extraction material is no homogeneous substance but exists of a lot of capillaries. At the beginning, the solvent enters the capillaries and solutes the extract. A solution with high concentration is produced here. So because of diffusion, a concentration change between the solution in the extraction material and the solution surrounding the solid particles take place. So at the end of the process, still a certain amount of solution consisting of solvent and extraction substance is retained in the solid particles because of adhesive forces, also known as underflow. This is the reason why practically no complete extraction is possible. The solution retained in the solid material has the same concentration on active compound as the extract shown in the figure. For equilibrium, it is assumed that the whole amount of active compound is solved in the solvent. For the extraction process, there are two different extraction processes with two different methods, which is continuous extraction, which has the method of replacement process and enrichment process, while the continuous extraction, which has the percolating process and the immersion method. I will start with the discontinuous extraction. So for the discontinuous extraction, two different methods are available. So firstly is the replacement process. The extraction material is contacted with fresh solvent and extraction takes place. Later, the underflow is settled and the miscela is withdrawn. The underflow is contacted again with fresh solvent and so on. So the disadvantage of this process is that with increasing extraction time, the concentration of the miscela decreases and therefore the recycling of the solvent becomes more and more cost-intensive. Secondly is the enrichment process. This method is used if the raw material offers the necessary percolating properties. In most cases, the solvent flows counter-current to the underflow through the apparatus, and by this way, very high concentration of the extract in the miscela are performed. So the advantage of this process is that it has lower operating costs and higher throughput compared to the replacement process. For the continuous operating extraction, following processes are available. Firstly is percolating process. The solvent passes through the non-moving solid material and extracts the soluble substances. The basic for this process is that the material has good percolating properties, which means that the solvent can pass easily the solid material. The advantage of this method is that the mechanical treatment of the solid material is low because of no movement, and further, during the passing through of the solution, a self-filtration takes place, resulting in a minimum content of fine solid particles in the extract solution. And the last one is the immersion method. For this process, the solid material dips completely into the solvent and is mixed with it. Therefore, no special percolation properties of the solid material are necessary. But the disadvantage of this method is that no self-filtration of the extract solution takes place, and therefore, a filtration step must be installed before the distillation step.
In conclusion, increase in concentration of mixture will lead to a decrease in volumetric flow. In addition, increase in concentration of mixture will also lead to an increase in pressure of the filter pump. Lastly, the percentage of solid in mixture and efficiency decrease as concentration increase. To get accurate result, there are several recommendations. Firstly, the slurry of calcium carbonate and water must be properly mixed. Secondly, when with the calcium carbonate powder, make sure to take the constant value. Next, the pump should never turn without the feed, and the feed pump must have a constant flow rate to ensure a zero value obtained, and proving that there is no pressure drop in the filter until the cake begins to burn.